Hey, what's going on, guys? In this video we are going to see how to find out the Laplace of t f of t, and we know that Laplace of f of t is equal to f of s. And also, if you watch my previous video, we have mentioned that when we have two functions together we cannot do the Laplace transform, but for this one we can do something. Here what we can do is, because if you look at the Laplace of this one, like here usually when we have Laplace of f of t, we find the Laplace like this. We take the integral from 0 to infinity and e power negative st, and we put f of t after that. But if it's t f of t, we had to put t f of t after that, t f of t dt. It's because here we have t f of t, that's why we put t f of t. If it's f of t, we have to put f of t alone. Okay, now for t f of t we can do something. We can bring this pattern from this equation, because if you write this one, like if you write this one in terms of integral form like this is going to be 0 to infinity, and then we will have e power negative st. I'm just converting this one, e power negative st, and we will have, after that, since we have Laplace of f of t, we will have f of t right here, and then dt, right? Now to bring the t in front, because here we have t here, to bring the t, what we can do is we can differentiate this one with respect to s. If we do that, we can bring the t, because if you differentiate this one with respect to x, we are going to have this one multiplied by negative t, because if you take the derivative of this one, this is going to be negative t, so we can multiply this one by negative t. So we can bring this pattern, because we want this one to be multiplied by t. That's what we are going to do right here, and this whole thing is equal to f of s right now. So what we are going to do is we are going to take the differentiation with respect to x both sides. So d over ds integral 0 to infinity e power negative st f of t dt. If you do this one for this side, we have to do the same thing for other side. So d by ds f of s. Okay, now if we move this one to inside, this is going to be a partial derivative of this one with respect to s, 0 to infinity, partial derivative of this whole thing with respect to s, e power negative st f of t, and in the other side we keep this one as it is, that is d by ds f of s. And here you can see this is the only function that is related to s. This one is related to t, so we just have to differentiate this one alone, because this one is just like a constant, so we just have to differentiate this one. If we differentiate this one, this is going to end up with 0 to infinity, and here we will have negative t multiplied, because if you take the derivative of this one, this is going to be negative t multiplied by e power negative st, and f of t remains the same, dt, this is dt, and in the other side we will have d by ds f of s, d by ds f of s. Let's put a bracket like this. Okay, so here you can see we can already almost brought this pattern. We had to have e power negative st. We are trying to find the Laplace transform of t of f of t, that is e power negative st t f of t. Here we have almost the same thing until this. We just have to get rid of this negative. So if we divide both sides by -1, this is gonna become 0 to infinity t e power negative st f of t dt, and that's going to be equivalent to negative d by ds, because I divided both sides by -1, so this negative cancels, and the other side we will have a negative. So this is going to become negative d by ds f of s, and that's it. That's the Laplace transform of t of f t, actually t f of t. Okay, now let's see how we can use this one. For example, let's say we have to find Laplace transform of t sin t. Laplace transform of t sin t. From the derivation, we know that if we can simply find the derivative, negative derivative of this f of s, that's going to give us the t of any function multiplies. So first we know if you watch my previous videos, we know that Laplace transform of sin t is equivalent to 1 over s square plus here we will have b square, so that's 1 square right here, since this is just 1t. So 1 square, this is the Laplace transform of sine t. Then to find out the t sine t, we just have to differentiate this one with negative d by ds, like negative differentiation. So instead of, so therefore we can say Laplace transform of t sine of t is going to be basically difference negative d by ds based on the derivation d by ds of this function, the Laplace transform of this, that's 1 over s square plus 1 actually, because 1 square is just 1, so we can just write it as 1. And here instead of writing this, we can also write this one as negative d by ds s square plus 1 power minus 1. And if you take the derivative of this one, this is gonna be minus multiply in front, that's gonna be just, it's gonna be plus, because minus that's gonna turn into plus. So we are going to have positive, and then this one remains the same, s square plus 1. Then we have to take the inside derivative, that's going to be 2s, and the power will become, we have to subtract 1 from the power, minus 2. And then we have to multiply this one by inside derivative. Inside derivative is just 2s. So multiply this one by 2s. So 2s is going to be in the numerator. So this is going to be 2s over s square plus 1 whole square. And that's the Laplace transform of t sine t. So whenever you have any function multiplied by t, if you can find the Laplace of the function that multiplies by t, then you have to just take the negative derivative, and that's going to be the t multiplied by any function. That's how we do that. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.